Hi everyone, this is Sumanth. In this video, we will just see what is p-value. So this is one of the most of the people will feel difficult when understanding this p-value. But in this video, let's decode this and let's understand in simple manner. So make sure to watch this video till the end. So if you just skip this video in the middle, you can't able to understand. So make sure to watch this video till the end, and also make sure to like this video and also subscribe to the channel as well. So yeah, with that, let's start this. So first, let's understand the definition for p-value. So I will just write the definition for p-value and let's understand that using that definition. So yeah, this is the definition, right? Probability of sample statistics given null hypothesis is true. So you won't be understanding anything as of now. So that's fine. We will just try to understand with an example. So before going to this p-value definition, before understanding this p-value with an example, you should understand what is null hypothesis. If you just watch this definition keenly, we just said that probability of sample statistics given null hypothesis is true. So sample statistics in the sense getting the sample from the population and performing some performing the statistics on that sample. So that's sample statistics. So what is null hypothesis? So if you just watch my previous video about null hypothesis, I just explained about what is hypothesis testing, what is null hypothesis, and what is alternate hypothesis as well. So if you didn't watch that video, make sure to watch that video first. So that's fine. Even in this video, we will just try to understand what is null hypothesis. So null hypothesis in the sense, this is a statement in which we assume everything is true. There is no difference. So there is no effect. So these kind of things we used to assume in null hypothesis. So the statements there is no difference, there is no difference, no effect. So these kind of statements we used to assume in null hypothesis. So yeah, let's understand this with an example. For example, let's take that. So in a class, height of students, the height of boys is equal to, so you can see we just assumed a statement like this is the class, and we just assumed a statement like there is no difference between the height, the average height between the boys and girls. So this is a kind of null hypothesis. We just assume that both boys, the average height of boys and average height of girls are equal, right? So that's null hypothesis. So such kind of statements we used to assume in null hypothesis. So yeah, that's null hypothesis. I hope you understood what is null hypothesis. And the next thing which you just want to understand before going to the p-value is the significance level, right? So yeah, significance level. So I hope you can understand my handwriting, right? Yeah, a significance level. So you just want to understand the significance level so that it will be easy for you to understand p-value. So the definition of significance level is, right, probability of type 1 error. So that's the definition of significance level. So what is probability of type 1 error? What is type 1 error? So this is type 1 error, right? Rejecting H0, the rejecting H0 when it is true. So in the previous we have just defined the null hypothesis, right? Both the average height of the boys and girls are equal. So what this type 1 error in the sense? So this is the kind of error in which we are just able to, we are just rejecting null hypothesis. Actually, the null hypothesis is true. Like in the previous example, the average height of boys and girls is true, right? They both are equal. But based on our statistical analysis, based on our calculation, we are just rejecting H0, right? So that's a kind of error, right? So significance level is the probability of rejecting H0 when it is true. So that's the significance level. So what's the use of significance level is? So this is a kind of threshold for us. So definitely if you just perform any kind of analysis or any kind of test, definitely there's a possibility of errors. So by keeping that in mind, we are just defining some threshold this significance level, right? So that's the use of significance level. We will just understand this also with example. So generally significance level will be defined using alpha, right? So for example, let's say generally we used to take the significance level of around 0.05, 0.01, right? These kind of numbers we used to take in significance level. So what's the meaning of this? What's the meaning of 0.05? What's the meaning of 0.01? So we will just understand 0.05 in the sense right? So you can see 0.05 in the sense there is a 5% chance of type 1 error. So there is a 5% chance that the actually null hypothesis is true, but we are rejecting that. So there is 5% chance. It means if you just take 100 sample statistics, and there is a in that 100 5 times there is a chance that we may reject the null hypothesis even though when it is true, right? 5 out of 100, so that's 0.05, 5% chance of type 1 error. So that's the significance level, that's the alpha. I hope you understood the significance level. So how you can just choose this alpha, like we just have 0.05, 0.01, right? So how you can just choose alpha? So it's depend upon the situation, it depends upon the problem statement and use case, right? It depends upon the problem statement and use case. So based upon our problem statement, based upon the use case, we used to define the define this threshold 0.05. Now, so I hope you understand what is null hypothesis and the significance level alpha. Yeah, this is quite a long video, so make sure to watch this video till the end. Stay with me, like we will just try to understand the p-value. Now let's try to understand the p-value, right? Now let's get into the p-value. Let's start with an example. So instead of explaining theoretically, let's understand this with an example. So I will just write an example here. So we just have a teacher, right? We just have a class. He used to take maths, right? Maths teacher. And now, so he just conducted a test, right? He just conducted a test. So average of the average marks of the class is mu is equal to let's say 55, right? 55 is the average marks of the entire class. Now he just thought that, so first before conducting the main test, let's give a assignment for the students so that there may be an improvement in the marks. So he just thought in that way. So he just given the assignment for the students. After that he conducted the test. Now for this scenario, let's take the mu as like question mark, right? Let's take this mu1 and this as mu2. Before the assignment is 55 and you just want to find what is the average after the assignment, like whether the students will score more than the previous one, or let's say will they score less than the previous one. So you just want to know that. So for this statement, for this problem statement, I hope you understood the problem statement. For this problem statement, let's assume a null hypothesis H0, assuming that mu2 is equal to 55, right? It's in the sense mu1 is equal to mu2, right? 55 is mu1, right? So mu1 is equal to mu2. So this is the null hypothesis which he assumed. So that's what we just discussed, right? Null hypothesis in the sense we used to treat everything is equal, nothing, there is no difference. So that's what we just, so there is no difference in the marks before and after the assignment. So that's what we just assumed in null hypothesis. And in alternate hypothesis, in HA, so we will just assume that mu2 is greater than mu1. So this is the alternate hypothesis. In null hypothesis, mu1 is equal to mu2, and in alternate, mu2 is greater than mu1. So now he just want to find, he just want to perform some kind of test, some statistical test, and he just want to either reject the null hypothesis, or let's say he should accept the null hypothesis. So to make a decision, he should perform some test, right? So for that, what he just done is, number one, declared the null hypothesis. He just assumed the null hypothesis and alternate hypothesis. And in number two, he just defined the threshold. He just defined the significance level, alpha. So he just taken that alpha is 0.05, right? This is the threshold which he just assumed. Alpha is equal to 0.05. And number three, what he did is, now he just taken a sample. He just taken a sample, right? So assignment, the one who have taken the test after completing the assignment. So he just taken, so in that group of students, he just taken some sample. Let's say some 10, instead of there are some 100 students. In that, he just taken some 10 marks. 10 marks. These are the people who have taken this test after the assignment, right? So these are the 10 marks we just have. Now he just found that the average of these 10 marks is he just got around 60, right? He just got around 60, the average of these 10 marks. Now we will just define the p-value, right? So what we just defined, probability of, so you can see at the starting we just defined, right, probability of sample statistics given null hypothesis is true. So this is the sample statistics, so this is the sample statistics, right? The 60, this is the sample, this is the sample statistics. So we just taken a sample and the average of the sample is 60. So this is the sample statistics. Now we will just define the p-value. So let's take this as x bar, right? Probability of x bar greater than 55, right? That's what we just assumed in alternate hypothesis, right? So probability of sample mean is greater than 55 given null hypothesis is true, right? So you can see we just define p-value is equal to probability of the sample statistics given null hypothesis is true. So how you can just find this probability? How we can just find this probability? So this can be found by using the test. We just have different kind of tests, right? Z test, a chi-square test, t-test, ANOVA test, right? So all these kind of tests we just have. So based on this test, we used to find the p-value, right? We used to get the p-value. So there are two ways you can just do that. So we just have Python, like we can able to do it with Python, right? So we just have some different kind of functions. So like when you just given this, when you just give this kind of statistics, like when you just give this, and it will just automatically, it will just return you the p-value. And the other way is we just have the z table. So we just have the z table. So using that z table, we can able to find. So for this value, for x bar greater than 55, so we can just see what's the p-value. So in the table, you can just look into the table and you can just find that. So these are two ways, and we will just discuss in the future, like both using the Python as well as how you can just find the p-value using the z table, right? So that's how you can just find the p-value, right? So when you just, after getting the p-value, now for example, let's say you just get the p is equal to 0.5. So what's the meaning of this? What's the p is equal to 0.5 means? It means that if we assume, right, if we assume h0 is true, so 0.5 means 50%. So there is 50% chance that the x bar is greater than 55, what you just got in the sample statistics. So if you assume h0 is true, there is a 50% chance that the x bar is greater than 55. And for example, let's say if p is equal to 0.01. Now the meaning of this is, if you assume h0 is true, there is 1% chance that this x bar greater than 55 is true. So similarly, for example, let's say you just have 0.05. It means there is a 5%. It means that if h0 is true, there is a 5% chance that x bar is greater than 55, right? So based on this, based on the p-value, whether we just reject the null hypothesis or we may not reject it. So for example, let's say in case 1, the p-value is 0.01, right? So this is less than alpha, right? Alpha, that is 0.05. So when p-value is less than alpha, then we will reject the null hypothesis, reject h0. So from that, we will just accept the alternate hypothesis. We are just rejecting the null hypothesis and we are just accepting the alternate hypothesis. And similarly in the second case, for example, let's say if we get 0.1, which is greater than alpha, right? Which is greater than alpha. So if p-value is greater than alpha, you may just think that we may accept the null hypothesis, right? So in the previous case, we just rejected it. Now we should accept it, but that's not the case. So the reason is we are just, so this analysis only for the sample, right? We just have the population. In that population, we just taken only one sample, right? We just taken only one sample. In this sample, the p-value is greater than alpha, right? But we are not testing it for complete population, right? So for example, let's say for any other sample, the p-value can be less than alpha, right? So we are not sure. So that's why if p-value is less than alpha, we can able to reject null hypothesis. But when p-value is greater than alpha, we should not accept the null hypothesis. Like we should able to perform some more tests on the, like we should take some more samples and we should able to perform some, similarly we should perform these kind of tests, and only then we can able to decide whether to accept the null hypothesis, right? We can able to easily reject the null hypothesis, but to accept it, we have to perform the sample, we have to perform this test on the entire population. So that you should remember. I know it's a quite a long video, but it's a very important topic that you just want to remember, the p-value. And I hope you understood the concept. So if you didn't understood, make sure to watch this video again. And even then, if you didn't understood, if you have any kind of doubts, make sure to comment down below. So that's all for this video. That's the p-value. Yeah, I hope this video is helpful. So if you feel so, make sure to like this video and also subscribe to the channel. So with that, I will just see you in the next video. Until then, take care and thanks for watching.